Okay, so the topic for this video is going to be parallel lines cut by transversal proofs, but this time with converses. Our essential question we're going to try to answer by the end of this video is how can I use a two-column proof to prove lines as parallel when lines are cut by a transversal? So this time we're going to be dealing with the idea of using some converses, which you hopefully remember back when we were talking about conditional statements. So let's see what we have written out here. It says, as Euclid continued to prove different geometric facts, he came to the conclusion that the converse of the corresponding angle postulate must also be true. We can use this to prove that lines are parallel. So if you remember, a converse is where we switch the hypothesis and the conclusion. The original corresponding angle postulate said, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. The converse here says if two lines are cut by transversal and corresponding angles are congruent, then the lines are parallel. We can kind of simplify it down by saying that the original one said if lines are parallel, then corresponding angles are congruent. And the new one says if corresponding angles are congruent, then lines are parallel. So this is going to be very beneficial if our goal is not to try to prove that angles are congruent, but if our goal is to prove that lines are parallel. So we have a super basic one here for example 1. It says use the corresponding angle converse postulate to prove that the lines are parallel. Okay, so let's just see how this works. So the given this time says that we got angle 1 congruent to angle 2. So we'll put that in our first statement with the reason being given. And we've got these angles being congruent. Notice though, we don't know that line A is parallel to line B. That's what we're trying to prove. But that's what we're saying. If we know that the corresponding angles are already congruent, the only way that that's going to be true is if the lines are parallel. So those angles being congruent by themselves are enough to say that these lines are parallel. And our reason, since they were corresponding angles, we will use the corresponding converse. The whole thing would be the corresponding angles converse postulate, but that's a lot of words. We're just going to write corresponding converse. And that's what we were trying to prove. So that means that as long as we know that those corresponding angles are congruent, that means that the lines must be parallel. Let's try to expand that a little bit here on example 2, because it's not just corresponding angles that should do the job. Example 2 says use the corresponding angles converse postulate to prove that congruent alternate interior angles must prove lines as parallel. So look at our given on this one. Our given says that angle 1 is congruent to angle 2. So let's put that down in our first box here. And let's look at angle 1 and angle 2. Notice, of course, that angle 1 and angle 2 are alternate interior angles. So let's see if that will prove that these lines are parallel. So the only way that we have to prove lines are parallel right now is that corresponding converse. But notice angle 2 is vertical with angle 3, right? So doesn't that mean that they must be congruent? And that's the vertical angle theorem. And then if 1's congruent to 2 and 2's congruent to 3, angle 1 must be congruent to angle 3 by the transitive property. Okay. But 1 and 3, those are corresponding angles, right? This is exactly what we saw up above. If 1's congruent to 3 and those are corresponding angles, that means that line A must be parallel to line B by the corresponding converse. So, turns out that, yeah, those alternate interior angles being congruent should also work as a way of proving that lines are parallel. And we really could do an example just like this one with alternate exterior angles. We could do it with same side interior angles. All of those angle pairs are enough to prove that lines are parallel. That's what we got right here on the inside. It says, after Euclid's work with the corresponding angles converse postulate, we can now use the following theorems. So we got the alternate interior angles converse theorem, saying that if two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. We've got the alternate exterior angles converse theorem, which does the same thing but with alternate exterior angles. And then we got the same side interior angles converse theorem that does the same thing but with same side interior angles. Just that, remember, same side interior angles are supposed to be supplementary, so you need to show that they add up to be 180 in order to prove that the lines are parallel. But all of this is to say that we can now use the converses of all the ones that we did in the last video as ways of proving lines parallel. Okay, so let's try some stuff out and you'll start to recognize the patterns here. So what do we have here? We've got a given that A is parallel to B and 1 is congruent to 3. Let's get those down. A parallel to B, angle 1 is congruent to angle 3. Those are both givens. Okay, so let's mark our diagrams. We know that these lines are actually parallel right now. And we know that angle 1 is congruent to angle 3. So this angle and this angle are congruent. Okay, and we're trying to prove that line B is parallel to line C. So in order to show that B is parallel to line C, we need to establish an angle pair between those two lines. And right now we don't know anything about 2 and 3, right? So let's try to get some sort of relationship between those. What we do know is that line A is parallel to line B. And which angles are formed by A and B? Well, that's angle 1 and angle 2, right? Angle 1 and angle 2 are alternate interior angles. So we use the alternate interior theorem to say that those are congruent. And once again, I can do that because we have in the given that A is parallel to B. Now, notice that I've got 1 congruent to 3 and 1 congruent to 2. That does mean that angle 2 must be congruent to angle 3 by the transitive property. Okay, now what kind of angles are 2 and 3? Because those are the angles that are formed by lines B and C, right? Well, if 2 and 3 are congruent, like we just said, that means that line B must be parallel to line C because of those angles. And what kind of angles were those? Those were alternate interior. So I'll say alternate interior converse. And there you have it. B is parallel to C. And I'm hoping that you guys saw my mistake that I just made in that one, because I made a mistake. I said that angle 1 and angle 2 were alternate interior angles, but that is a big lie. Those are alternate exterior angles. Okay, so there we have it, right? We use those original parallel lines of A and B to say that 1's got to be congruent to 2. Then we use the transitive property to establish that 2 is congruent to 3, and that gave us enough information to say that B must be parallel to C because of that alternate interior converse. Okay, what do we have here? Let's see what's going on here. A is parallel to B, 2 is congruent to 3. Let's get those down first, and then we'll take a look at what we're trying to do. Okay, let me mark the lines that we do know is parallel, A and B. We're trying to prove that C is parallel to D. We also know right now that angle 2 is congruent to angle 3. But that's not enough to say that C is parallel to D because angle 2 and angle 3 don't share any lines. So we got to do a little bit of work to establish that. Now, I like to start with the parallel lines that we do have, which is A and B. And if I'm looking at A and B, the two angles that are being formed there are angle 1 and angle 2. So angle 1 and angle 2 do have to be congruent because they are with parallel lines. And the reason they are congruent is because they are alternate interior angles. So I'll use the alternate interior theorem to get them to be congruent. And then I've got 1 congruent to 2, and I already had 2 congruent to 3. So that means that angle 1 must be congruent to angle 3 by the transitive property. And then what can I do? Well, I mean, 1 and 3, those use line C and D, right? Which is what we're trying to prove. And if 1's congruent to 3, that means that C has to be parallel to D. And that's because of angle 1 and 3. And angle 1 and 3 are alternate exterior angles. So this will be the alternate exterior converse. And there we have it. C is parallel to D. Let's try a few more. What do we have here? It's a similar diagram. We've got C parallel to D and 1 congruent to 2. C parallel to D and 1 congruent to 2. Of course, those are given. Let me mark 1 congruent to 2. And we're trying to prove that A is parallel to B here, but we don't have an angle pair that uses A and B. The lines that we do have parallel are C and D. And the angles that are being formed by C and D are angle 1 and angle 3. Now, what kind of angles are 1 and 3? Those are alternate interior. So we'll use the alternate interior theorem to get them to be congruent. And then, just like the last ones, I got 1 congruent to 2, I got 1 congruent to 3. That's going to let me say that 2 is congruent to 3 by the transitive property. And then what kind of angles are 2 and 3? Because those are actually the angles that are being used with lines A and B, right? So if those 2 angles are congruent, that does prove that A's got to be parallel to B, as long as we can identify which converse to use. And that should be pretty clear that that's the alternate interior converse, because 2 and 3 are alternate interior angles. And there you have it. We proved that A is parallel to B. Okay, so last one here, example 5. What do we have here? We've got A parallel to C and angle 1 congruent to angle 3. Both of those are given. Get my given down. Let me mark my diagram with A parallel to C. We're trying to prove that B is parallel to C. Okay, well, if A is parallel to C already, let's start there. What angles are being formed by A and C? And this might be kind of tricky to see, but if I'm just looking at these, then the angles that are being formed are 1 and 3. But that was already in the given. Oh, you know what this should have been? It should have said A is parallel to B. I'm sorry. That'll be changed on yours. Let's change it to A parallel to B. If A is parallel to B, then I can say that 1's congruent to 2, because those are corresponding angles. And then if 1's congruent to 2 and 1's congruent to 3, that means that 2's going to be congruent to angle 3. By the transitive property. Oh, and 1 was congruent to 2 because that was the corresponding postulate. Can't forget that. And then what can we do from there? Well, 2 and 3, if we're actually looking at 2 and 3, those are the angles that are using line B and C, which is our goal here. So in order to get B parallel to C, then we can use 2 and 3. Those are alternate exterior angles, so this will be the alternate exterior converse. And there we have it. We did it. We proved that B is parallel to C. Okay, so you should try the ones on your turn here. You got example 1 with a new diagram, and then you've got example 2 with a new diagram as well. Hopefully you guys can figure those ones out. Give them a shot, see what you can come up with, and then come back to this video when you're ready to check. All right, so for this one, we got C parallel to D. We got angle 1 congruent to angle 3. Those are both given. Let me mark that. I know that this line is parallel to this line, and this is congruent to this. Well, what do we want to do here? If those lines are parallel, then what I can say, it's kind of tricky to notice here, but C and D being parallel does allow me to do angle 1 with angle 2. Angle 1 and angle 2 here would be alternate exterior angles. So that'll be the alternate exterior theorem. And then I've got 1 to 3, 1 to 2. That's going to give me 2 congruent to 3 by the transitive property. And 2 and 3 are the angles that are being used for lines A and B. So that's going to allow me to say A is parallel to B. 2 and 3 are alternate interior. So this will be the alternate interior converse. That was kind of tricky to visualize. Next up, example 2. We've got A parallel to B. We've got angle 2 congruent to angle 3. All right, so these lines are parallel, and these angles are congruent. Now we're trying to prove that C is parallel to D, but let's use these lines that we do know are parallel. We know A is parallel to B. So looking this way, notice that using A and B are 1 and 3. So I can say 1 is congruent to angle 3 because those are alternate interior angles. And that's the regular old alternate interior theorem if you're saying that the angles are congruent. I've got 1 congruent to 3, I've got 2 congruent to 3. That means that 1 is congruent to 2 by the transitive property. And then if 1 is congruent to 2, those two angles do use lines C and D. And if they're using lines C and D, then we can say that C and D are parallel, and 1 and 2 are corresponding angles. So this will be the corresponding converse, will be the reason why those lines have to be parallel. So angle 4 in there was a little bit of a distraction. We didn't need to use that. All right, hopefully you guys feel all right about that. But that's it for this video.